Hey, everybody. Let's take a moment to draw a picture of a speaker and see if we can figure out the physics behind it, trying to explain kind of each of the parts. Sometimes it's a little hard to understand how it all comes together. So, this hopefully will be helpful for you. I'm going to go ahead and draw my speaker kind of pointed to the right and all the different parts. And I'm going to start out with the speaker cone. So, actually, I'm going to draw this part in black, I think. So let me go ahead and put my speaker cone in here. And ooh, that's a little smaller than I want. There, let's make it like that. All right, let's try this. Nice big fat speaker cone. Looks pretty good. We'll put in some lines for the cone itself coming down this way. Yeah, nice big cone. All right, and then somewhere around in here we have a straight part that is a voice coil. It puts it together. So here I've got this speaker cone, which is often made out of cardboard, sometimes other things, but commonly out of cardboard. And near the bottom of it, we insert a magnet. Now the shape of the magnet itself is a little bit hard to see here. If I was to draw it kind of on a side, it's actually typically kind of a donut shape like this, and usually almost like a cylinder, if you can picture it there. And then in the middle of that cylinder, we would put in another kind of post in the middle of it that's there, and that provides a magnetic field that is always pointing either inwards or outwards, depending upon how the magnet itself is magnetized. So the way I'm going to draw this here is I'm going to draw it as kind of this oddly shaped, almost like rectangular thing to help us to understand it kind of on edge. So if you can picture this for a moment as this rounded, you know, bit, it'll make more sense. So uh, in this particular case, I've got this post in the middle, and let's say that the post itself is a north pole, and then surrounding that is this kind of south pole and south pole. It could be the opposite way around. It really doesn't matter. But what it does mean is that the way that this whole thing is polarized is it goes from north to south. Um, and if I was to put in some magnetic field lines here, they would run from the north to the south, just like this, uh, in this part. And in the lower part, they would run from the north to the south, but down here, right, north to south is in this direction. And if I could show them kind of in the post itself, it would be running like straight out at you. So at this point, the kind of magnetic field is coming like right out toward the south, because this is in 3 dimensions, but I'm kind of drawing it in 2 dimensions, sort of. What we usually do is we would then wrap a voice coil around this, right? So an actual wire kind of coming off from some source. So I would have a wire that would move in here, and it would be wrapped kind of up and around this middle post. Now, by no means am I showing all of the wrappings. Usually it has a lot of wires that are there in order to make this work, but I'm just showing some of them. And you'd have some sort of source down here, right? And that source is variable in current. And so if I was thinking about this, you know, like a waveform, you know, that's here, um, that current would be rising and falling, right? Where, you know, it's positive at some point and negative at another, meaning that it's moving one direction for a moment and then it moves back the other way and then back this way and back that way. Because what's really going on inside the speaker itself, if we use the right hand rule, I can go ahead and figure out kind of what the speaker cone is doing. It's either being pushed outwards or it's being pulled inwards. So the third right hand rule that's here, remember, is the FBI. So here's my I for my current. And in this particular case, let's say that the current here is flowing up this way, therefore kind of down here. And so as it comes in, it's up in all of these coils right there as it's coming around. So I could say the current is up at that point. The magnetic field, if you remember, is always kind of radially outward along that. So however you want to tilt that. So at the middle point where I was showing that the current is going up, then the magnetic field itself is kind of coming out of the page, if you could picture that, like out at you. So I now have a current that's going upwards, and I've got a magnetic field that's coming out of the page kind of at you, which means that the force on this coil is actually to the right. So these wires that are connected to the speaker cone right here are actually being kind of pushed outwards at that moment. And so the speaker cone is pushing on the air forward and sending, these compressions out into the world. And then if I was to turn the current around, like the opposite direction, now my current is downwards, but my magnetic field is still kind of out of the page. And now my force is going the opposite direction, and it is pulling that speaker cone back in again. What's fascinating about that is that by just varying the current, having the current, traveling one direction for a moment, it pushes the cone out, turn that around, and it pulls the cone back in again. And if you get that kind of motion in and out, then you can create any sound you want. And so we can record sound from our voice or a musical instrument, and we can reproduce that back again when I want to create the sound at the other end. So I use a microphone, which in many ways, a microphone is very much like a speaker, because if I could just, talk into this part here, it would move this coil in and out from this magnet, and I could generate electrical signals that way, and I could then store those. It just means that we really need to have some very lightweight material here that can be moved in and out by my voice. Very lightweight, wires that are coming into it, and be able to store it, which is why we do things like using two different diaphragms and checking the distance between, or a little ribbon and having that vibrate, or the membranes themselves. We need lightweight things that can be pushed around by air, and that's what a microphone is. And then a speaker, on the other hand, we can have it much more robust, because we can drive a speaker like a big fat speaker, right, as we're thinking about it, to be able to move a lot of air and to be able to produce huge amounts of volume, because the more air you move, the greater the volume is. So nonetheless, this is the end all and be all of speakers. Right here is that idea of, I have this magnet, right, that is polarized radially outwards. I wrap that wire around the inner core and have current that is varying in between it, which moves that speaker cone in and out, which then creates the sound waves themselves, or the compressions and expansions or rarefactions in the air itself. And then somewhere over here on the other end, there's an ear. That's a poor looking ear, right, that's on the side of somebody's head. Maybe here's my ear that's hearing the sound on the far side, and whoever this is really enjoying that sound over here. All right, so there it is. Hopefully you understood something from this, and I will see you all next time. Adios.